Hello, Internet! Today we have a very simple task. We want to write a web application just in pure Python. And as you can see here on my left-hand side, I have here my Spyder IDE. So this is pure Python. And what we're going to do, we're going to use StreamLIT. And the beautiful people from StreamLIT say, well, it is very easy to build your own app in pure Python. This is it. Import StreamLIT as st. Then you have your numpys, your pandas, and all you have to do if you are in a Python application is just to say, hey, you know what? The only thing we have to do is say StreamLIT run my Python file. And this is it. And this is exactly what we're gonna do. And what you do not see here, because of course I have multiple screens and now it's again outside of your screen and my screen and all screens. And here we are, and you see here, oh wow, suddenly we are here in our web browser and we get some results. Now the first thing we want to do is, what can we do? At first here, the word, we can have that our page has a certain title. You see that our browser here says, hey, cosine. This is a calculation for the cosine similarity of our word to vec embedding. And you even can have a little icon, and I've chosen here smiley. And then you say, hey, to put a heading, it is quite easy, or a title to the page. You just say, hey, streamlit.title. Amazing, and the complexity of this language is wow. Next thing, you can have a header, my panda data frame of word vectors. And then you just say, okay, now imagine this is somewhere a page in the internet where you say, okay, what I would like that somebody can just download his word embedding file. You remember last time we did the word to vec, purely coded in TensorFlow 2. And we got a file where we have for each word our word vector in 128 dimension. And this is exactly, we're gonna now have a file uploader that will be the shell that will take our CSV file with all the word embedded vectors. And what we do is very easy. I just want to have this in a sidebar since we do this only one time. So I say streamlit.sidebar. Wow, amazing. Then you can have a header and then you just say, hey, activate the file uploader. And you can have it, give it some text, and you can say, hey, only for TSV files. And then this is it. So let's have a look at this. If there's something that you need, and the nice thing is to see, you see it here in real time. This is here my sidebar. I have here upload. Remember, this is my header here, upload. And then I say drag and drop file here. Currently it's limited to 200 megabytes per file. And as you remember, I said, hey, only TSV, and you can drop or browse your file. So what I'm gonna do now, I'm going to open my file explorer. I choose a beautiful file from a screen you cannot see, but don't worry, because it is just a simple file. And here we are. Here's my file coming in. You see it? Yeah, this is it. Yeah, and just release it, and this is it. Now to bring it in the system, you just say, hey, submit. And this is it. So you have your upload process done in your web browser. And congratulations, now you have a file. And since it's a TSV file, you do know what's gonna happen now. Panda data frame. Yes, you are right. This is it. So how we do this? First, this was the whole code for the sidebar to publish it in an app. So pure Python, not bad at all. You can draw maps, you can have your PyDeck chart, whatever. But let's stay simple, let's stay plain. We say, hey, this is my file from my word embedding. Oh, okay, so here in the browser you see this is it. This is great. And then you can say, okay, So show me the file, show me the panda data frame. And there are quite a number of commands you can have. You can just say, okay, let's do this command. StreamLIT.dataFrame. Wow, this is complicated, huh? This is complicated, yeah? And then you have a width in pixel and a height in pixel. Or if you want to make it really simple, and I am a real simple guy, therefore just say, hey, StreamLIT.table, and show me the first 5 lines. This is all I want. StreamLIT table. And here we go. This is it. We have a column for our words. You remember, we have a data set where we had, I don't know, how many sentences, 300,000, 500,000, 1 million sentences. And then we said, okay, now we find out our vocabulary size. And for each word, we do a word embedding. We have now a 128-dimensional vector where, just wait for it, 128-dimensional vector. Here it's coming up. Yes, here we go. And this is it. And so for each word, we have now an encoded vector representation for this particular word. And this was one of the results from my, and as you can see here, word2vec in pure TensorFlow 2. And I showed you this was the end result in our last video. And now what we want to do, very easy, we want to have a similarity measurement. So what we do here is now, you say, hey, can I choose a specific word? And since you remember, we had a text of scientific projects, so this means we also have physics and theoretical physics and high energy physics and elementary particle physics. Yes, you know it. Quantum field theory. Yes, here we go. And we said, okay, let's go with the Higgs boson, with Higgs. And this is a very nice, simple method to have here a textual input field here in our app, coded in pure Python. And you know what it is? It is one line. It is exactly this line that I show you here. It is, hey, StreamLIT, text input. My goodness, this is complicated. It is one line of code. And then you can just, for confirmation, you write, hey, your current search word is exactly my input word. And so, you know, verification, yeah, input arrived, my current search word is Higgs. And then what do we do? Yeah, we have now, since it's a pure Python file, you can do whatever you like from Python. You have here your cosine similarity. You can take it from wherever. I'm a nice guy. I show you, okay, I make it a very simple way. I define it myself. And then I say, okay, and then I have a function where I say, okay, cosine run. And now it calculates the cosine similarity from my word Higgs to each other word in my vocabulary. Now, if you remember, last time I showed you that the number of words in our vocabulary you have to choose. Last time we've chosen a go with the full vocabulary size of our input dataset. And remember, last time we had a vocabulary size of 105,000 words. So what it's going to do, it's going to calculate the dot product, the cosine similarity, the normed cosine similarity, for each of those 105,000 words with a 128-dimensional vector representation. And it's very simple calculating all the cosine similarity. And it shows you, it ranks you the results according to their cosine. And here we have it. And this is a very simple data frame that comes out. And then we just say, hey, run is done. Finally, finished. Beautiful. This is it. This is your app. So your user can go say, hey, this is here my word embedding file. I have it here on my local disk. By the way, this is Spyder from Anaconda, and I'm running here on a Windows 10 laptop. Very old laptop, so no problem at all. You just put in your word embedding file here. You say submit. It's in the system. You choose your word here, and the cosine similarity for all other vocabulary words is calculated. And this is your very beautiful short app where you can say, okay, Given I have a classical word-to-vec model, this is it. So there's one trick you have to be aware of. As you can see, this is performed almost in real time. On the left-hand side, you have your Python file. On the right-hand side, you have your app in specific, I think I have Firefox here, in your web browser. And now what you want to do, you want to optimize it. And the nice people over there at StreamLIT, they have here, they had a cache function. And it was very easy, streamlit.cache. And the function you defined would be cached. And of course, they did some optimization. And today you have two specific accelerator cache functions if you want. And one you use if you want to return your data. And one function you should use if you hold non-data objects. You should use the singleton. Now, in our specific case, since I want a Panda data frame back, I can say, okay, beautiful. Instead of streamlit.cache, I go with experimental_memo. So what this allows you, if you run this now another time, the beauty is that it is really, really fast. So let's say we change something here, just a little bit, just place a nothing in here. And then I go here and I say, okay, in Python, save my file. And you can say it comes up here, if I do this the first time, here on the top right side with rerun or always rerun. And I said always rerun. So whenever I change something here in my Python file, please, I want to see it immediately here in my other web application here. So, and this is done and beautiful. And you see, this is the effect if you have this cache operational. However, if you have now, let's say, a new word, and instead of Hicks, what are we gonna do? We're gonna have some urban. And as you can see, press enter to apply. So you just press enter and the whole start from the very beginning. And you can see here, where now we have here the command running, cosine run. This is my function that I defined, my cosine run here in Python. It is running, it is calculating for all 100k words in 128 dimension. It is calculating the cosine similarity. And there are a lot of options you could accelerate. But hey, this is just for StreamLIT. So we let it run. And as you can see, if you do it the very first time, it takes quite some time. Also, this is run on my laptop, so on an absolutely non-optimized hardware. It takes some time, but you know, all good things come to an end. Yes, finally, and here we are. And you can check just for semantic reason. Hey, the words that you found, does it make sense? So I have here with urban, this is my target word if you want, and now find me all the semantically similar words in my input sentences that I provided the word-to-vec algorithm to be trained on. And this is the result. It says, you know, close to urban, I found, based on your input text you provided for word-to-vec, cities, rural, area, city, singular, socio, hey, resilient, livable cities, unbelievable communities, resilience, citizens, oh, human beings living in a city, crisis, housing, futures, trends, societies, and whatsoever. So very easy. You can send this to your friend and say, hey, just drop here your word embedding file, just submit it within your web browser, and the app calculates the cosine similarity in, I don't know, even if it's 256 dimensional word embedding, no problem at all, whatever. And you have an app. And this is the beauty. If you know Python, as you can see here, I have chosen here my Spyder. Choose whatever IDE you love, you are familiar with. Then you have this simple command where you say, StreamLIT run my Python file. Wherever you are in an Anaconda command file, whatever, activate it, and you get a left-right presentation where you can play around and you see building an app is as easy as hell for your data science project. So I hope you enjoyed this. And yes, of course, I almost forgot. Unbelievable. If you want to learn more about StreamLIT, there is a very, very good presentation from the nice people of StreamLIT where they show you, hey, beautiful, you know what? Get started in under 1 minute. We have 3 simple principles. Embrace the scripting I showed you with a very simple Python. Weave an interaction. You can have sliders, you can have date pickers, you can have whatever, and you can deploy your freshly built app instantly. And plans start from completely free. Let's explore this. And as you can see here, you have an open source library we just used. And then even StreamLIT, if you say, hey, where can I host my app? There is a starter package that is free. It is free forever. It is built and share apps with the world. It's great for students, your first open source project, anyone looking to test out StreamLIT. Very nice. Of course, it is limited to 1 gigabyte. You have public apps. You have here quite a lot. Of course, if you want to have a professional application, you're working in teams, it costs you some money. But as always, the last thing I want to show you, that the documentation is really, really nice. So how I use it, I normally go here, and I showed you we are operating within the limit of the StreamLIT library. We have a get started, we have our API references, and then if you want to push it to the cloud, we have a StreamLIT cloud, or wherever you want to host this. This is beautifully. So, coming back to our StreamLIT library, you have a very nice getting started, the installation, create an app, using StreamLIT's core features to fetch and cache data, draw charts, plot information on a map, have interactive widgets like I showed you, slider, whatever you like. If you just know Python, no HTML, no CSS, no JavaScript, no nothing. Easy, very nice, simple application, StreamLIT library, get started. It is great. You have a very good documentation. And if you have questions about the API, and if you want to say, hey, how can I have here my data display elements? What is available within StreamLIT? You have your Panda data frame, you have a table, you have your JSON files, whatever. What are my input widgets? You have a very nice documentation. You just then select, I don't know, what did we use? We use a file uploader, remember? And our file uploader, and yeah, by the way, we are StreamLIT version 1.5. And then you have here your API, your beautiful parameters listed in details. You have an example. So it is a very easy application. Build your own web app from your data science project. I discovered it just 1 day ago. I played around a little bit. It is very intuitive. If you want to show the world what you did in your data science project, give StreamLIT a try. Thank you, and I see you in the next video.